question 1a from the differential equation given so that we can form dy over dx equals to 3y minus x square y. We can form this equation into separable of variable method, which is y over 1 over y dy equals to 3 minus x square dx. This is because this equation is now in form fy dy equals to gx dx, and it satisfies the condition of separable differential method. For Roman 2, we need to find the general solution by using separable differential method. So we need to add integral both sides. So we will get integral 1 over y dy equals to integral 3 minus x squared dx. So we will get ln y equals to 3x minus x cubed over 3 plus c. Then we need to add exponent to both sides. We will get exponent power of 1y equals to exponent power of 3x minus x cubed over 3 plus exponent c. So we will let exponent c equals to a. So that we need to replace exponent c to a, that we can find the general solution is y equals to a exponent 3x minus x cubed over 3 is a general solution. Okay, to find the particular solution for y, okay, we know that x equals to 0 and y equals to 2. So we need to replace x, which is 0, and y, which is 2, so that we will get 2 equals a exponent power of 3 times 0 minus 0 power of 3 over 3. So we will get a equals to 2. So the particular solution is y equals to 2 exponent power of 3x minus x cubed over 3. Okay, for question B, if you find the exactness of the differential equation, we need to form the equation so that we will get y per x squared dx minus 1 over x dy equals to 0. So we know that m equals to y over x squared. So the partial derivative of y is 1 over x squared. And for n, we know that negative 1 over x. So the partial derivative for x is 1 over x squared. So since partial derivative of y and partial derivative of x is equal, so that we can conclude that this equation is an exact differential equation.
Assalamualaikum, and my name is Nurul Izzah bin Hashim. So today I will continue my friend's manual work. So I will present coding for question 1a, which is the given differential equation of the dy respect to dx is equal to 3y minus x square y. Okay, so in coding, we need to define the symbolic variable, which is here we are declare y as a symbolic function of x and c as the constant, and then we need to define the differential equation, which is to set up a differential equation to match the format of the problem. And next, um, to solve using the separation of variable, we need to display the general solution, and finally, this is the command print the general solution obtained from the symbolic computation. So next, we need to find the particular solution for y. given x equal to 0 and y equal to 2, we need to define the symbolic variable, which is this line is declared as y as a symbolic for function of the variable of x. This will enable the symbolic operation to be performed as y. And then we need to set up the differential equation, which is this line is define the differential equation, which is dy respect to dx is equal by y in bracket with 3 minus x squared, and in a way that MATLAB that can understand. And then um, to display the result, this command is print the particular solution derived from the equation to the command window. And next, to solve this equation, um, the dSolve is function attempt to find the general solution of the defined differential equation. And lastly, the line instruction in the MATLAB to the solve equation again with the initial y equal to 0 and y equal to y equal to 2 and x equal to 0, which is help to find the particular solution, and this is the answer.
Okay. For question B, check the exactness of the differential equation. Step 1, we need to define variables. We declare x and y as symbolic variables, allowing MATLAB to perform symbolic calculations. Step 2, define functions. Here, m and n are defined based on the rearranged differential equation. Step 3, partial derivative. We calculate the partial derivative of y and partial derivative of x using the different function. For step 4, output result. This section prints the computed derivative to the command window for verification. Step 5, exactness check. This conditional statement checks if the partial derivatives are equal. If they are, it confirms that the equation is exact and outputs the appropriate message. Next is question C. We need to given dy dx, we need to find the particular solution for differential equation using the exact method. What is exact method? Exact differential equation is a first order differential equation able to be arranged in the form of mxy dx plus nxy dy equal to 0. The first step of exact ODE is we need to write the ODE in the standard form of exact ODE mxy dx plus nxy dy equal to 0, and check for the exactness of the ODE that fulfill the same partial derivative of m and n. This is since partial derivative of m and n is the same, it is an exact differential equation. The next step is we discover Ixy by integration of x as an independent variable. Ixy integration of m dx plus fy. We will get the value of I. The next step is step 3, discover fy by differentiating Ixy with the respect of y. We will get x squared plus 2xy plus f prime y. The next step is comparing partial derivative of I with the respect of y and xy. After comparing the both sides, we will get f prime y equal to -1. The next step is integrating both sides. We will get fy equal to -y plus c. The next step is step 4. Step 4, we need to substitute fy into ixy from step 2. We will get I, and we will write the general solution in form of ixy equal to c. After we write the general solution, we will apply the initial condition, which is y 1 equal to 2. Change the value of x equal to 1 and the value of y equal to 2. We will get the value of c is 13 over 3. Then we will substitute c into the general solution that we get before. And we will get the particular solution for the differential equation using the exact method.
For question C, first we need to define variables and function. What it does, this part create two functions m and n based on the variable x and y. The same command sets x and y as symbols, which means you can use them in equations. For step 2, we need to calculate partial derivatives. What it does, this calculate how m change when y change, the partial derivative, and how n change when x change. Then it shows this result on the screen. 3. Check if the equation is exact. What it does, this checks if the two derivatives are equal. If they are, it means the equation is exact, which means it can be solved easily. It tells you whether it is exact or not. 4. Apply initial condition. What it does, this part define a potential function that combines x and y, then it applies a specific condition when x equal to 1, y should equal 2, and shows the result on the screen. In summary, the code defines two functions and calculates how they change. It checks if the equation can be solved directly. It applies a condition to find a specific solution. The result helps in understanding the equation's behavior and solving it effectively. That's all from us. We will end our presentation with question 1. Thank you for listening.